Hello, my name is Kelly Hong. Today's date is February 7th, 2020. I'm presenting my portfolio PowerPoint that will be focused on the reproductive system and specifically the hormonal control loops of the non-gravid female reproductive system. As a quick overview, the menstrual cycle is defined as when female humans produce gametes in a monthly cycle. This is characterized by a 3 to 7 day period in which bloody uterine discharge called menses or menstruation occurs. The menstrual cycle includes changes in both the ovary and the uterus, and this is known as the ovarian cycle and the uterine cycle, respectively. The ovarian and uterine cycles are under very complex hormonal control. The hormonal control of these cycles follows the standard hypothalamus, anterior pituitary, and peripheral organ sequence. Gonadotropin-releasing hormone, or GnRH, is released from the hypothalamus, and this goes on to stimulate gonadotropin hormones to be secreted from the anterior pituitary gland, including follicle-stimulating hormone, FSH, and luteinizing hormone, LH. These two gonadotropin hormones go on to stimulate steroid and peptide hormone secretion from the ovaries, and that includes estrogen, progesterone, inhibin, and anti-Mullerian hormone, or AMH. There are 3 phases to the ovarian cycle: the follicular phase, ovulation, and the luteal phase. The follicular phase is the period of follicular growth in the ovary. Granulosa and thecal cells begin to produce steroids, including estrogen, which is the dominant hormone in the follicular phase. Other notable events in the follicular phase include the LH surge and the much smaller FSH surge. The LH surge triggers necessary chemical signals for oocyte maturation, and the FSH surge helps thicken the endometrium in preparation for possible pregnancy. The follicular phase is also the most variable in length, ranging from anywhere between 10 to 21 days. Ovulation follows the follicular phase. Ovulation occurs when the ovary releases the oocyte into the fallopian tube, or it is carried away to either be fertilized or will undergo atresia, which is a form of apoptosis like death. Finally, the luteal phase is characterized by the transformation of a ruptured follicle into a corpus luteum, which secretes hormones including progesterone, estrogen, and inhibin to prepare further for pregnancy. When pregnancy does not occur, the corpus luteum spontaneously undergoes the aforementioned apoptosis-like death and becomes an inactive structure known as the corpus albicans. In the luteal phase, progesterone is the dominant hormone. Now we will discuss in detail the hormonal controls of specific phases of the ovarian cycle. During the early to mid-follicular phase, low levels of estrogen result in negative feedback signals to inhibit GnRH secretion from the hypothalamus and consequently also inhibits FSH and LH secretion from the anterior pituitary. Simultaneously, estrogen functions as a positive feedback signal onto granulosa cells of the developing dominant follicle, which increases estrogen-only secretion. AMH functions to prevent excess follicle development. During the late follicular phase, granulosa cells of the dominant follicle secrete progesterone, inhibin, in addition to estrogen. Increased levels of estrogen and progesterone result in an LH surge, which is necessary for the final steps of oocyte maturation. A much smaller FSH surge is partially inhibited by inhibin accompanying the LH surge. The FSH surge is also necessary for crucial steps in preparing for pregnancy by thickening the endometrium. During ovulation, the now mature follicle secretes prostaglandins and various enzymes to dissolve the connective tissue that holds follicular cells together. The follicle wall will then rupture and the egg is swept into the fallopian tube, where it either undergoes fertilization or atresia. During the early to mid-luteal phase, follicular theca cells and former granulosa cells transform into the luteal cells of the corpus luteum in a process called luteinization. The corpus luteum increases the amount of progesterone, estrogen, and inhibin. Estrogen and progesterone exert a negative feedback signal to inhibit further GnRH secretion from the hypothalamus, and subsequently also inhibits in FSH and LH secretion from the anterior pituitary. Progesterone secretion aids in further preparation for pregnancy by converting the endometrium into a secretory structure. Endometrial cells then deposit lipids and glycogen into the cytoplasm, providing nourishment for a possible future embryo, while the placenta, the fetal-maternal connection, would also develop here. When pregnancy does not occur, as we are focusing on the non-gravid female reproductive system, the corpus luteum will perish after approximately 12 days. The corpus luteum spontaneously undergoes apoptosis, and the remnants of the inactive structure become the corpus albicans. Estrogen and progesterone secretion will decrease, thus halting the negative feedback signal on the hypothalamus and anterior pituitary. This causes FSH and LH secretions to start back up again as a new menstrual cycle prepares to begin. This slide from Silverthorne demonstrates the ovarian cycle in a clear and concise manner. The section with the purple background here demonstrates the follicular phase in which a dominant follicle matures and hormone levels gradually rise. The section with the green background in the middle demonstrates ovulation, in which LH and FSH surges will occur, and the mature oocyte is released from the mature follicle. Estrogen levels are at their peak during ovulation. Finally, the section with the yellow background shows the mature follicle transformed into a corpus luteum, and ovarian hormone levels gradually rise again before diminishing once again. At this stage, the corpus luteum becomes an inactive corpus albicans as the cycle prepares to repeat itself. Now we will discuss in detail the uterine cycle, which has 3 phases that correlate with the 3 phases of the much more complicated ovarian cycle. The first stage is menses, in which bleeding from the uterus occurs and correlates with the beginning of the follicular phase in the ovarian cycle. The second phase is the proliferative phase. During this phase, the endometrium adds new cell layers in anticipation of pregnancy. This phase correlates with the late follicular phase of the ovarian cycle. And now this is the secretory phase. This correlates to the luteal phase of the ovarian cycle. Here, the hormones from the corpus luteum convert the thickened endometrium into a secretory structure. When pregnancy does not occur, the superficial layers of the secretory endometrium slough off and are lost. This phase correlates with the luteal phase of the ovarian cycle. This diagram provides a great visualization of the uterine cycle. As menstruation begins during the menses phase, the endometrium, shown as the pink layer in the middle of the diagram, begins to thicken. During the proliferative phase, the endometrium continues to thicken with new cell layers. Finally, during the secretory phase, the endometrium layer gradually becomes thinner as superficial layers slough off when pregnancy does not occur. This diagram provides an accompanying timeline in days as well. Finally, there are two diagrams demonstrating the correlation between the ovarian cycle and the uterine cycle, as both parts are part of the menstrual cycle. These images provide a good timeline to the life cycle of the dominant follicle as it transforms into a corpus luteum and eventually as a corpus albicans when pregnancy does not occur. The image on the right, taken from silverthorn, neatly provides hormone fluctuations and basal body temperature fluctuations with each phase of the menstrual cycle. This concludes my portfolio presentation on the hormonal loop control of the non-gravid female reproductive system. Please find my references listed in the slide above. Thank you for listening.